right, I think this is where we stopped. So remember that when you're looking at one of these, this is LD50, and then LD50 is the dose of a chemical or toxin that kills 50% of the individuals in the study, right? And then you've got the threshold, which is a little bit different. The threshold, or sometimes it's called the toxin threshold, same thing, right? Okay, that's going to be the lowest dose where you start to see an effect. So maybe that you can start seeing that person become dizzy or disoriented or nauseous or something like that. Like that's the lowest dose that you're going to start seeing any effect of the toxin. And then there's the ED50. ED50 is the amount of toxin that causes a non-lethal, so it doesn't kill, but a non-lethal effect in 50% of the individuals. So your examples there could be like infertility. So you're not looking to kill, but trying to determine what is the amount that 50% of them become infertile, or 50% of them get cancer, what have you. Okay, so your answer here was 5.5 hypothetical units, because here's your threshold right here, but your LD50 was right here, so it's about 5.5. Then you went on to the next one. Some of you guys are really confused by this one, but let's look at it. I'm going to grab a highlighter. Alright, so based on the data above for Stream in Illinois, which site is most likely to have a construction site immediately upstream from it? So think about construction site and what you're going to get. You're going to get a lot of dust, or aka particulate matter, right? And a lot of that particulate matter is going to go in the water. And once it goes into the water, it's going to make the water cloudy. So you're looking at turbidity. Okay, and so turbidity is the cloudiness of the water, because there's so many insoluble particulates. And so which one had the cloudiest water? And that would have been this one right here. That's the highest. And then you could also look at the total dissolved solids, and so there was 2,000 milligrams per liter here. So that could have given you some direction right there. But nothing else would have really given you direction. And so this probably is your answer. So that's site C. Not probably, it is your answer. Okay. Find this one. The material rotating in the Pacific Ocean is mostly consisting of. Alright, so we talked about ocean dumping. And so this right here, we specifically talked about the Pacific Ocean patch. Pacific Plastic patch, sorry. And I remember I told you that that is an area of the Pacific Ocean, kind of north, where there is so much plastic that it's like the size of Texas. Like, it's so insane. There's so much plastic. And so your answer right there was solid waste, mostly plastic, right there. Okay. The next one, compost. This was like a very specific question. Sorry about this one, but this one was very specific. But if you're not remembering what compost is, some of us remember, some of us don't. So compost is decomposing organic matter. In a controlled environment. You should have remembered the fact that your favorite documentary that we watched with the farm, remember Alan, I think that was his name, the guy who died of cancer, but anyways, Alan showed them how to create compost using worms and things like that. So it took them a while, but they had this big pile of what kind of looked like dirt, and it was really just compost. Which is mostly dirt, but a lot of decomposing organic matter. So if you're eating your vegetables or whatever, instead of throwing them in a plastic bag in the trash can, it's better to put it in a compost bin, because then you're going to end up with the soil microbes decomposing that organic matter, which allows for us to keep some of that organic matter from our landfills, decreasing the amount of methane, because you know that anaerobic decomposition of your food waste increases methane, and methane is a greenhouse gas, and so that's why we get that methane in landfills. So if we're composting, we can use that compost later for our plants and our soil, or you can sell it if you can't use it. So one of the biggest issues with a compost bin is that it must be aerated, otherwise it starts to stink, to control the smell. One of the positive aspects is that it keeps that anaerobic respiration from occurring in the landfills. And what that does is that it's going to lower the CH4 coming, the methane coming from those landfills, from all of that decomposition. Anyway, so it's supposed to be a 30-to-1. It was supposed to be your answer. It was a very specific answer. If you got this one wrong, please don't freak out, because that one was like super specific. Alright, so the next one is poses a health risk to humans who eat large quantities. So your swordfish, sorry, that's the key question, that's the key one. So this is going to be your fish. Okay, what you should have put was mercury. Here's what happens is that you end up with combustion of fossil fuels. Either that's through coal combustion or vehicle combustion, it really doesn't matter, but combustion leads to an increase in mercury levels in the atmosphere. And so then that mercury goes into the ocean. It's dissolved in ocean. And then it is methylated. In other words, it is converted to methylmercury. Because it's converted to methylmercury, this allows for an easier uptake. By the algae. And the biggest thing here is going to be obviously biomagnification, because you're going from algae with that mercury, the methylated mercury, which is then eaten by zooplankton. And then there's even more mercury, right? Which is then eaten by the small fish. So even more mercury, which is then eaten by the larger fish. So even more mercury, which is then eaten by you. And you get the most of that mercury. Because that's how biomagnification works. Remember, biomagnification is going to be the increase of a toxin up the food chain, which is different from bioaccumulation, which is just the increase of that toxin within the individual organism. All right, so that's why mercury is that answer. ED50, I already answered that earlier. Your answer is going to be the effective dose that causes 50% of individuals to display harmful effects. Okay, so that's on the previous page. Moving on, number 25. Which would help best to protect against inland and coastal flooding in urban areas? Well, wetlands. Okay, so wetlands, that is their ecosystem service, is that they protect the coastal areas. So preserving the wetlands, that is its ecosystem service. It's what they do. The wetlands and mangrove forests also detoxify the water. They also get rid of pollutants. They're also habitat. So all of that good jazz. So the next one, bacteria beneficial to wastewater treatment, and that's going to be in your secondary treatment. We just went over that earlier, and so they naturally break down organic matter. Remember, that is an aerobic requiring oxygen process, and so they break down that organic matter into what we call sludge, which can then be used as fertilizer later. Okay, and that's that secondary treatment. Okay, the next one is the persistent organic pollutants. It says, which of the following describes the way that persistent organic pollutants can harm the environment? And so if you don't remember what POPs are, these bioaccumulate in the fatty tissues of organisms. And so some examples might include any medications, especially hormonal medications. Sorry, there it is. Hormonal medications or steroids, things like that. Pesticides like DDT. Dioxins. PCBs, those are going to be your flame retardants. Perchlorates, and those come from your rocket fuel. Anyway, so the answer to this one was C. Persistent organic pollutants are soluble in fat, and they're going to accumulate in the fatty tissues. So the next one asks, many synthetic chemicals such as PCBs act as estrogen mimics. In an ecosystem, these persistent chemicals would have the greatest effect on which of the following? That would be the secondary consumers. Remember, they biomagnify. Up the food chain. Okay, so that's why it is the secondary consumers that are going to get the majority of it. Okay, so the next one says, in a river ecosystem, the dissolved oxygen, remember DO, concentrations drop quickly, probably because BOD has increased. So you've got a point source input of organic matter. That organic matter really could be anything. Could be fecal matter, poo, right, due to CAFO that's nearby, sewage, or it could be fertilizer due to an agricultural business nearby. Remember what a point source is? Point, you can point to it, so it's easily identified. So you can point to that source, so you can point to that CAFO, you can point to that sewage drain. So since the dissolved oxygen concentration has quickly dropped, we know that the bacterial activity has increased. We call that BOD, biological oxygen demand. That bacteria use up the O2. Okay? So the bacteria use up the O2. It's biological oxygen demand. Always when the DO is low, the BOD is high. There's more decomposing bacteria and they're using up that oxygen. Alright, so next one. Scientists warn that the increased rate of antibacterial soaps kill bacteria, but they don't kill all of them, only kill 99.9%, so that other 0.01% doesn't go away. It is more adapted, so it survives, reproduces, and then becomes that dominant bacterial strain. Okay, so why is it a future health problem? Because the soap promotes the evolution of bacterial resistant pathogens. Remember, pathogens are anything that can make you sick. Okay? Alright, so moving on. Number 31. Try to find number 31. Which of these laws, the laws are the hardest ones to remember, I think, because you have to really try to remember them. Mandates the restoration and maintenance of chemical, physical, and biological integrity of the nation's waters, and that's going to be the Clean Water Act. Okay, so if I were you, I would put that on a flashcard. I mean, that's the only thing that helps you remember stuff. It helps me remember stuff. The next one says, which of the following best explains why top predators can receive up to 60 times as much persistent organic pollutant as their prey, and up to 600 times as much pollutant as the producers. So the only one that makes any sense here is this one right here. Persistent organic pollutants are going to accumulate in the body fat of organisms. That's bioaccumulation. That is the actual definition of bioaccumulation. That's the actual definition right there. And then POPs increase in concentration and move up the food chains. That's biomagnification. Okay, so that is the actual definition of biomagnification. Okay, so if you remember this, I think you guys drew this. You may not have, I don't know. But I feel like we drew it. So we've got a small fish that's eaten by a bigger fish, that is then eaten by an even bigger fish. And so if we're thinking of persistent organic pollutants, this small fish has some of it in its fatty tissue. The larger fish has way more. And then the largest fish has the most. Okay, so in each individual, that's bioaccum. So that's bioaccumulation in each individual. But as you go up the food chain, that's biomagnification. Okay. Moving on, number 33. Major anthropogenic sources of nitrogen pollution. So nitrogen pollution includes fertilizers, vehicle exhaust, industrial pollution, and I would say anything that has to do with poo. So anything that has to do with poo, and so the answer there, discharge of sewage into waters. So that sewage, that poo, contains fecal coliform, poop bacteria, and also high levels of nitrogen, phosphorus. Okay, so what's the difference between a point and a non-point? All right, because one you can point at, no you can't. So point, non-point. Okay, so a point source is easily identified. You can point at it. Okay, and so your example would be that sewage pipe. Like you can point at a sewage pipe, like, oh, there it is. Your non-point, not as easy because it comes from multiple sources. So your example would be like a watershed with pollutants. From a city. And maybe it's a city and a farm and an industrial complex, but like it's all these different things all at one time. So that's your non-point. So your answer here, your a point source can be targeted for reduction because you can find it. A non-point source is easily identifiable. No, it's not. Non-point sources are less harmful. No, they're not, because they're harder to figure out. Non-point sources tend to be factory outputs, not necessarily. They could be agricultural as well because they're a mix. Point sources tend to be agricultural. Nope, because it could be sewage. It could be a CAFO. So it doesn't necessarily have to be, a plot of land with corn on it. This you were just supposed to know, like the nitrogen cycle, you were supposed to know this. So the nitrogen cycle, and I feel like I've given you guys this question like a lot, but okay. It was actually this one right here. So this is your atmospheric nitrogen. Plants cannot use it in this form. This is what 78% of the oxygen, 78% of the air is. It's this form of nitrogen. And then it gets fixed. So this part is nitrogen fixation. So it can be fixed by bacteria, or it can be fixed by lightning, or by us making fertilizers. So bacteria is the biotic way it can be fixed. Lightning and us making fertilizers would be the abiotic ways of doing it. And so it gets fixed to, looks like ammonium. It could also get fixed into ammonia. So you can get ammonia as well. Then our plants can use that, and so we call that assimilation. Plants can use ammonium in their tissues. Furthermore, you're going to have what we call nitrification right here, where you're going to get nitrite and nitrate, and again, plants can use that as well. And then you have right here denitrification. Denitrification is when that nitrate or the nitrite is then converted back into atmospheric nitrogen, all to start the process all over again. You should definitely have this written down it's not real hard to remember. So that was the answer. It was B. Man-made pond constructed to hold animal waste. That's called a manure lagoon. Alright, and so remember that a manure lagoon is for CAFOs. And then CAFOs are your concentrated animal feeding operations. They must be lined with a plastic, and you must have clay underneath them, just like a landfill. So you have to have clay soil underneath them. But unfortunately, if it rains, you might have a lot of that sewage or that manure leaching. So can leach nitrogen, phosphorus when it floods. And so obviously that nitrogen, phosphorus goes into the nearest waterway. Alright, so next one, number 37, try to find it. Okay, why is recycling plastic an example of open loop recycling? Give me a minute, I gotta go open the door. Alright, so getting back to it. So, if you did not study this, you have closed loop and open loop recycling. Closed is when you go from plastic to plastic. And that's all you can do, depending on the type of material. Open is when you can go from plastic to something else, essentially. Okay, so your answer okay, so plastic bottles can be recycled for production of different plastic bottles. Which of the following is likely to result from the destruction of the surrounding wetlands? Okay, so your answer to this one was the increase of flooding. So when you have less rooted plants, then you increase erosion and decrease topsoil. All of that can increase flooding. That's why wetlands are necessary for the protection of the coastline against flooding. Okay. The next one you were supposed to just kind of know. I remember there was a song about this. Reduce, reuse, recycle. So that one you were supposed to know. So most desirable to least desirable. Alright, so to decrease the likelihood of cultural eutrophication, from the effluent. Effluent is the discharge water. From sewage treatment. That's what that is, if you were worrying about what that word meant. And then eutrophication is like this cascade of events. First thing that happens is that you're going to increase the amount of nitrogen and phosphorus in the water. Second thing that happens is that because of that extra nutrient, the algae is going to grow out of control. But because algae is an R-selected species, it's going to die quickly. And when it dies quickly, the bacteria that decomposes it is going to increase and going to use up more oxygen. And so we call that the BOD, the biological oxygen demand, which is then going to increase the oxygen that's already there. And so you're going to cause what's called hypoxia, which can then lead to a fish kill. And that is the process of eutrophication. Okay, so this would include this right here. So to decrease the likelihood of eutrophication, you want to add a part of your tertiary treatment to remove the nitrogen and phosphorus. Okay, so the next one says, what is the benefit of using water in the industrial system in a closed system, just like reusing that hot water? Because you're going to decrease what we call thermal pollution. Because thermal pollution, or the increase of warm water in an ecosystem, is going to decrease the amount of dissolved oxygen in that aquatic system. Because whenever you add warm water to something, you're going to cause the gases to come out of that liquid. This will eventually cause hypoxia, which is the lack of oxygen. And also, if organisms are not adapted to that temperature, you might cause death amongst them because they cannot survive, because that temperature is out of their range. So it's out of their tolerance range. So the answer to this question is going to be A. Alright, so what is the first step in treating wastewater? We've already talked about that. You're going to get rid of solid stuff. Alright, 43. This one was really kind of confusing and messed up, and I'm sorry about that. But the answer to this one is E. This one right here. Okay, so you're going to have DO being high in a normal environment And then right here, you've got some sort of point source pollutant that goes into the water that increases the nitrogen phosphorus. And so your BOD goes up, so BOD goes up, but your DO goes down. Okay, and so there's your discharge. And so then right here, you're going to have where it starts to normalize. This is your oxygen sag curve. And remember, that has to do mostly with rivers. Okay, so that was the answer there. This one is another law. Drinking water is that one. Kind of feel like that was obvious. The next one says the rise of MSW. Remember, MSW, it's municipal, solid waste. Had a brain fart there. Trash, essentially. And we're talking about developing countries, so your most obvious answer to that is going to be the growing populations and the mass production of consumer goods for developed countries. Okay. And the last one. Yay, finally, done. Mercury concentrations were measured in freshwater shrimp populations in 2 different ponds. One of those ponds, let me do that. One of those ponds is polluted with mercury and the other one is not. So let's say here's my pond 1. This is the one that's polluted. Polluted. And here's my pond 2, and this one's unpolluted. That's a word, I think it is. So this one's not polluted. This is my experimental group. So the experimental group is going to be the polluted pond. And my control, the one that I'm going to compare to, is my unpolluted pond. And so you're going to have a similar food web. That's a constant right there. So what's kept constant? The same food web. Which of the following best identifies a scientific question? Okay, so don't forget to make sure you can identify independent variables. That's going to be the amount of mercury. And then the dependent variable, that's going to be whatever is measured in the end, which in this situation is the accumulation of that mercury in the tissues of the organisms. Okay, make sure you can identify experimental group, control, independent, dependent variables. Okay, so the answer to this question was A. Okay, there you go. Alright, so whatever you got wrong, make sure that you review.